Next learning outcome under subtopic stress and strain is discuss the graph of stress versus strain for a metal under tension. The shape and magnitude of stress versus strain curve of a metal will depend on, first, its composition, next, heat treatment, prior history of plastic deformation and the strain rate. Next is temperature, and the last one is state of stress imposed during the testing. Seal apparatus used to determine the Young modulus of a material may be used to investigate the behavior of a wire under increasing stress. Loads are added to stretch the wire, and the corresponding extension is measured until the wire breaks. The behavior of a steel wire can be deduced from force versus extension graph or stress versus strain graph as shown in figure 11.1. The behavior of the material under tensile test can be explained into 5 stages. First, point A. Point A is known as proportional limit. Point B, elastic limit. Point C, initial point of plastic deformation. Point D, the ultimate stress or the ultimate strength. E, fracture. Path OAB represent elastic deformation, whereas path CDE represent plastic deformation. Point A, proportional limit. The force increases linearly with the extension until point A. The straight line graph path OA obeys Hooke's law, which states below the proportionality limit, the restoring force is directly proportional to the extension. From Hooke's law, Fs equal to negative Ke. Fs is stand for restoring force. K is stand for Hooke's constant, and E is stand for the extension. The negative sign indicates that the restoring force is the opposite direction to the increases of extension. Gradient of OA represent the Young modulus. The Young modulus can be determined only where the Hooke's law is obeyed. Point B, elastic limit, also known as yield point. Point B is the elastic limit of a material. Below this point, the wire experiences elastic deformation. It returns to its original length with the removal of the force along the path BAO. But beyond this point, the material is permanently stretched and will never regain its original shape and length. If the force is removed, the material has a permanent extension OT. The area between the two parallel lines AO and CT represent the work done to produce the permanent extension OT. The work done in stretching the wire is completely recoverable. The yield point marks a change in the internal structure of the material. Yield stress is defined as the stress after which material extension takes place more quickly with no or little increase in load. The plane of the atoms slide across each other, resulting in a sudden increase in extension, and the material sinks uniformly. Point D, ultimate stress point. Point D is a breaking point where the strength of the material is breaks. The stress associated with the point known as breaking strength. The force on the material is maximum and is known as the breaking force. This is sometimes called the ultimate tensile strength. Beyond point D, the necking is start to occur. Point E, fracture. After the necking occurs, the material is failed at point E, known as fracture point. The metal breaks at E where the atomic bonding between atoms is destroyed. The behavior of a material can be deduced from graph stress against strain. Figure 11.2 shows the example of graph stress against strain for aluminum, copper, glass, and steel.